another question on functions which says that express 9x squared minus 6x plus 6 in this form. So this is basically a question on quadratics. So we could use the method of expand and compare, or we could use the algebraic identity, which I'm going to use here. So I'm going to write 9x squared as 3x squared whole square, then minus 2. A is 3x and B is just going to be 1 because we already have 6x here. So it's going to be 1. Then you have to add square of 1 and subtract square of 1. And then there was a plus 6 with the question. These three combined give us 3x minus 1 whole square. And these two combined give us plus 5. So 9x squared minus 6x plus 6 can be written in completed square form, 3x minus 1 whole square plus 5. Okay, part 2. State the smallest value of p for which f is a one-to-one function. It's saying that now the domain is greater than equals to p. Let's first sketch this curve. The turning point is going to be, you equate this to 0, so then you get 1 over 3 as x, and y is always this thing. So y is 5. So turning point is 1 by 3 and 5. So we have a turning point here, and the graph cuts the x-axis, the y-axis at 6. So it's going to be a graph like this. This would be 6. Okay, now that is clearly not a one-to-one function because a one-to-one function passes the horizontal line test. The horizontal line should cut this function on one point only, but it's cutting it at 2 points. So this is not a function whose inverse is possible, or it's not a one-to-one function. How does it become a one-to-one function and x should be greater than equals to p? We have to find the smallest possible value of p. So the smallest possible place this function can start from so that it becomes a one-to-one function, or so that the horizontal line test passes. Because now, if you're only looking at the green line, now the horizontal line only cuts the green line at 1 point. So now it's a one-to-one function, and the minimum value that p can take is going to be 1 over 3. So p equals 1 over 3. Okay. Part 3 is find f inverse and then the domain of f inverse. Okay, let's find f inverse first. F can be written in the completed square form, which was 3x minus 1 whole square plus 5. Remember, you can only take inverse of a quadratic function when it is in completed square form, and you can easily make x the subject. So it's going to be y minus 5 square root plus minus equals 3x minus 1. 1 will add when it goes to the other side. 3 will divide equals x. So this is equals to f inverse of x. Now we have to decide whether we'll choose the positive sign in between or negative sign. What was the domain of f of x? Domain of f of x is greater than equals to p. So greater than and equals to, we got 1 over 3 earlier. So since it's greater than and equals to some value, so this will be positive. That is because the domain of x is equals to the range of f inverse of x. So if this domain is increasing, this range is going to be increasing as well. Okay. And next we have to find the domain of f inverse. So domain of f inverse equals range of f. Now, how do we find range of f? Let's go back to this graph. This graph was starting from 1 over 3. And at 1 over 3, the value of y is 5. So range of f is, fx is greater than equals to 5. So the domain of domain of f inverse of x is going to be the same. It's going to be greater than equals to 5 because the domain of f inverse is equals to range of f.